This story goes back to the year 2006. Scientists all over the world suddenly detected something unusual in our atmosphere, a dangerous gas called methane. What shocked them most was how fast its levels were rising. And even today, they continue to increase. Now, methane is not just any gas. It's a natural gas, but when it escapes into the atmosphere, it traps heat on Earth far more effectively than carbon dioxide. Think about a cold winter night. When we wrap ourselves in a blanket, all the heat stays inside. In the same way, methane acts like a thick, invisible blanket wrapped around our planet, preventing heat from escaping into the space and causing the Earth to warm even more. When scientists first noticed this sudden spike in methane levels in 2006, they immediately suspected human pollution, emissions from industries, oil fields, and natural gas production. But when they began investigating carefully, they discovered something far stranger. This rise in methane was not just caused by humans. It was coming from deep within the Earth itself, a hidden secret that the planet had been keeping for thousands of years. So, what exactly is happening? Where's all this methane coming from? And most importantly, does this mean our planet is approaching some sort of natural disaster? Or is it a warning sign of a massive climate shift? To understand that, we need to go back, far back, into Earth's history. The scientific community already knew that large spikes in methane have happened before. In fact, these spikes naturally occur once every 100,000 years. How do we know this? Scientists drilled deep into ancient ice sheets in places like Antarctica and Greenland to collect what are called ice cores. Picture this. Every year, a fresh layer of snow falls on these frozen lands. Tiny bubbles of air from that year get trapped in the snow, and as new snow falls on top, those bubbles are sealed away. Layer after layer builds up for thousands of years. When scientists extract an ice core, they're essentially pulling out a frozen time machine, a record of Earth's atmosphere, year by year, century by century. By studying these layers, scientists have learned something amazing. Every 100,000 years or so, the Earth experiences a big spike in methane, and every time that happens, it signals the end of an ice age. A period when massive ice sheets melt, oceans rise, and Earth's temperature shoots up. The last big methane spike occurred about 12,000 years ago, at the end of the last ice age. That's when huge glaciers melted, sea levels rose, and humans entered what's known as the Holocene epoch, the warm, stable climate we still live in today. But here's the mystery. If these spikes usually happen every 100,000 years, why did we see another one so soon, in 2006, just 12,000 years later? To solve this puzzle, we need to look at how Earth's climate works over long periods. We're living in what geologists call the Quaternary period, which began about 2.5 million years ago. This period has had two main parts. The first is the Pleistocene epoch, which lasted until around 12,000 years ago. During that time, Earth went through repeated ice ages. Gigantic glaciers would cover huge parts of the planet, then melt away, then return again in cycles lasting tens of thousands of years. It was during this time that humans evolved, and it was also when giant animals like mammoths disappeared forever. The second part is the Holocene epoch, the warm, stable climate we still live in today. For the past 12,000 years, Earth's climate has been much more stable, allowing humans to settle, farm, and build civilizations. Glaciers shrank, rivers flowed, and agriculture became possible. But technically, scientists say we're still in an ice age, just a mild one, because there's still ice at the poles. A true end to an ice age would mean no polar ice at all. So what actually ends an ice age? Scientists have identified three main factors, called Milankovitch cycles. Eccentricity. Earth's orbit around the sun slowly changes from a perfect circle to an oval shape over 100,000 years, altering how much solar energy we get. Axial tilt. Earth tilts slightly as it spins, changing between 22 and 24.5 degrees over a 41,000-year cycle. A greater tilt means warmer summers and faster melting at the poles. Precession. Earth wobbles on its axis like a spinning top every 19,000 to 23,000 years, shifting the timing of the seasons. Together, these cycles control how much sunlight reaches Earth and when. When the planet warms, ice begins to melt. And here's the critical part. Melting ice exposes dark ground or ocean water, which absorbs more heat than shiny white ice. Even more importantly, melting ice releases greenhouse gases like carbon dioxide and methane that were trapped in frozen ground or deep under the ocean. These gases then cause even faster warming, creating a powerful feedback loop. So, if this is all natural, why did methane levels suddenly spike again in 2006? Human activity did play a role, especially during the 20th century when oil and gas industries grew rapidly and leaked large amounts of methane. But by the 1990s, these human emissions had actually leveled off. So something else must have triggered this new surge. Modern satellite technology gives us a clearer picture than ever before. Special instruments send laser beams towards Earth in wavelengths that only methane can absorb. If the beam doesn't bounce back, it means methane is present. Using this method, scientists have mapped methane leaks across the planet. Some leaks are massive. In Iran, NASA detected a methane cloud 3 miles long over a huge landfill, releasing more than 70,000 tons of methane each year, equal to the weight of 180 jumbo jets. In Turkmenistan, oil and gas facilities are leaking hundreds of kilograms of methane every single hour. But these industrial sources explain only part of the problem, less than half. A much larger share of methane is coming from northern forests and wetlands, where frozen ground called permafrost is melting. As it thaws, ancient plant and animal material buried for thousands of years begins to rot, releasing methane into the air. And here's the danger. Methane is extremely hard to capture once it escapes. In landfills or gas fields, we can sometimes collect it and burn it to turn it into carbon dioxide, still harmful, but far less dangerous than methane. But methane leaking from vast wilderness areas can't be captured at all. Once in the atmosphere, methane stays there for about 10 years before breaking down naturally. Plenty of time to heat the planet significantly. The worrying part is this. Throughout Earth's history, methane spikes like this have only happened at the end of major ice ages. But today, glaciers have already shrunk dramatically, and now we're seeing methane levels higher than anything recorded in this kind of warm climate. This suggests that Earth may be shifting into an entirely new phase. But what does that mean? Are we heading toward a planet with no ice at all? A fully ended ice age? Or could this somehow trigger the start of another glacial cycle? The truth is, no one knows. Scientists have no historical reference for methane levels rising so high just 12,000 years after the last big spike. And if this process is natural rather than caused by humans, stopping it might be impossible. This is why the methane mystery matters so much. It's not just about pollution or greenhouse gases. It's about understanding whether Earth itself is changing in a way we've never seen before, and whether humanity is ready to face what comes next.